Hi everyone, this is GKCS. In this video, we are going to be talking about security in a distributed system. This is a lesser known concept, I think, because you don't really have the time in an interview to deep dive into security aspects. And also, as an engineer in your day-to-day life, you don't really dive into each one of these concepts. You're insulated to some extent by your IT team or by the infrastructure which has already been made through open source tools or maybe senior engineers. So this is a good space to learn, but even in an interview, it could help you if they go into one aspect. The first part of security is verification. Verification is a mechanism by which you can tell that the request is coming from a human being. Are they even a human being? Is the request worth looking into? With the advent of ChatGPT and GPT-4, what's happened now is you're able to break CAPTCHAs regularly. You can look at an image which has, let's say, really broken text. I bet you that I can run this through a CAPTCHA and break it. Okay, it's not very hard. So they're able to recognize characters, they're able to recognize images, they're able to tell, which of these have street signs in them, which of these have mountains in them. Google has its own CAPTCHAs, and they're able to break that. So I don't know where the future of CAPTCHA is going. The second thing is SSL and TLS. This is more on the verification of the server, the web server which is actually serving the page to you. We are not going to be looking into this also because it has mainly got to do with security algorithms. TLS3, SSL, when you see HTTPS on your browser, you know that the page is safe. And encryption algorithms, this is again something we are not going to be looking into. ECC, elliptic curve cryptography, RSA, Diffie-Hellman are not what we are going to be looking into. And the reason we are not going into depth here is because this is just pure math, pure algorithms. There's nothing that you will be learning as an engineer which will help you tomorrow to design or build these systems. All of these algorithms are extremely well used. They're open source. And so understanding these algorithms also do not make much of a difference in your day-to-day life as an engineer. Okay, the only thing where you can see a significant difference would be which version of TLS are you using? Are you using TLS 1.2 or 1.3? And are you using which version of SSL? Primarily because you're looking at performance. Okay. Otherwise, it's all about public keys and private keys. So this part we are going to be removing. There is another part that we are removing, which I should have mentioned as -1, digital rights management. How do you ensure that a video which is supposed to be viewed by your customers in India is not viewed by your customers in the US? This is a problem that Netflix probably faces. How do you ensure that a video is visible only to your paid customers? Okay. We are going to be touching on that problem, but we are not going to be looking at it in depth. We are not going to be counting the number of IP addresses through which the user is connecting. We are not going to be looking at whether they make a copy of the video on the local file and what if they share it with other people. No. Okay. Digital rights management is totally different. We are not going to be looking into that either. So now it's clear that verification and digital rights management, this, if you're truly interested, you can look at Fairplay. Okay. The links are in the description below. And for verification, you can look at some of the links in the description for CAPTCHA, SSL, TLS, and some encryption algorithms. This is more like for fun. Okay.